So today's topic is about arcs and central angle. So we're going to start with central angle first and tell you what an arc is. Okay, so central angle of a circle is what you may expect. It's just an angle with its vertex at the center of a circle. That's it. Okay. So imagine a circle, right? Well, actually, you don't have to imagine there. You can see one. You see the angle YOZ? Okay. That's a central angle. Okay. It's an angle with its vertex at the center of the circle, and then the two sides are the radii, right? So that's basically what it is. Okay. So write that down. Yeah, I'll wait. So that's what a central angle is. Now, and YOZ, there you go. YOZ is the central angle. Who wants to tell me what an arc is? It's right there. How about Hannah? Go ahead. Yeah. Oh, just right here. An arc. What's an arc?
Oh, an arc is an unbroken part of a circle.
Yeah, that's it. Very simple definition. So here, in this picture again, do you guys see an arc in this picture? The unbroken part of this circle? Yes. What is it? Yeah, YZ. And so you see the arc YZ? That's an arc. Okay. I think you may have seen that before in intro or something like that. Okay. So there. So you could have the arcs. You could actually separate this into two different categories. Actually, major arc and minor arc. Okay. I don't know if you guys remember this from intro. So here, does it remind you a little bit? Okay. So here, let me show you. Okay. So YZ right here. By the way, guess what this little symbol means on top of it? Yeah, that's the symbol for arc. So when you're representing arc, that's what you do. Okay, instead of writing arc YZ, you could do that little mark. Okay, so this is a minor arc. Major arc will be YWZ, and of course half of the circle. These are semicircles. Okay, so is semicircle major arc or minor arc?
Major arc.
Actually, semicircle is neither. Semicircle is semicircle. It's just half of the circle. So here we go. And also, let me tell you also that in order to name minor arcs, how many letters do you use? Two. For major arcs or semicircles, how many letters do you think we use?
3 or more.
Actually, just 3. You don't need more than 3. Okay, but that's fine. But why do you think we would need 3 letters to represent a major arc? Why not just use 2? For example, if I wanted to name this major arc right here, YWZ, why not just say YZ? The reason is kind of obvious, okay? Yes, how about Chris? Reagan, Chris.
Because if you use 2, it would just be the small.
Yeah, it'll be that small minor arc, okay? So for minor arcs, we use 2 letters. For major arc, we need to use 3 letters. Does that make sense? Right? Because if you imagine if I'm talking about this major arc and I just said arc YZ, right? You'd be saying, well, which one are you talking about? The major arc or the minor arc, right? So that's why we use 3 letters for major arcs and 2 letters for minor arcs. Why do we then use 3 letters for semicircles as well? Why don't we just say for semicircles, you could just say YZ, can't you? Then that's half of the circle. Kaylee, why would you need 3 letters?
Because you don't know which side.
Exactly. If I just say YZ, you don't know whether I'm talking about the top part of the circle or the bottom part. You see what I mean? So for the major arc semicircles, we need 3 letters. For minor arcs, we just use 2. And this is what they're saying. Who wants to read this for us? How about... I don't know if you... no, let's not read that. It's sort of more confusing when you read it. But you get the idea. It's a very simple idea. Okay, so basically we use 3 letters for major and semicircles. We use 2 letters. And so forth. Okay? Are we okay with that? Questions? All right, then let's move on. So it turns out we could get measure of a minor arc. Okay, so here's the definition. How do we define measure of a minor arc? Well, it is defined to be the measure of its central. Anybody? Angle is correct. You guys remember this? You did this in intro, believe it or not. So if you look at this picture down here, what's the central angle of this angle YOZ? Class? 50 degrees. So by definition of measure of the minor arc, guess what this measure of this minor arc is? 50 degrees. Okay, so that's really easy. It's the same exact angle measure as the central angle. Is that okay? So Notice for measures we put that little m in front. Okay, if you're just kind of like measure of an angle, right? Measure of stuff angle, we put m. Just like that, we put m for measure of an arc and so forth. Okay, so if this YZ is 50, guess what the measure of this major arc will be? Oops, they tell you. YWZ. What would then, if this minor arc is 50, what would the measure of this major arc be? How about Katie? What do you think?
310.
Yeah, very good. How'd you get 310?
Subtract 50.
Yeah, you know that the whole thing is 360, so if you subtract 50 from that, you get 310. Right? Easy enough? Well, what would the measure of a semicircle be then? Actually, for every semicircle, the measure of the semicircle is always same, right? Jonathan, what would that be? What would the measure of a semicircle be? Huh? 180, yeah, exactly. So, pretty straightforward. So every time you have a semicircle, the measure of it is always 180. Okay. Any questions? One thing you got to be careful though is this. The measure of the actual arc has nothing to do with actual length of these arc. What do you think I mean by this? Because a lot of times people get this confused. The measure of the arc has nothing to do with actual length of arcs. So for example, if this arc, one of the arc has measure of 50 degrees, another arc has a measure of 50 degrees. Is it guaranteed that both of these would have the same length? No. Why not? Why not? Okay, some of you see it. Why wouldn't, just because I said one arc has length of 50 degrees, the other has length of, not length, measure of 50 degrees, why would they not both have the same length? Some of you see. I want you to discuss this with your group because this is really important. You understand. Go ahead. What do you guys think? Why? All right. Who would like to tell us why? How about, okay, some of you, what did you guys come up with? Youngwoo, what did your group come up with?
The circle could be bigger.
Exactly. You could have a very small circle versus really big circle, right? Just because the central angle measures 50 degrees, right? If you have a really big circle versus smaller one, right? The measure of 50 degrees for one circle, the length of the arc of 50 degrees may be different than, it'll be a lot smaller than, right? The arc with the bigger circle with 50 degrees measure, right? Very good. Okay, so that's the idea. Okay. But it does tell you how many percent of the circle we're talking about, right? Like for example, if I said arc measure is 180, right? You know it's half of the circle. If I said arc measure was 90, you know it's 1/4 of the circle, right? That we're talking about, right? But that makes sense in that case. But actual length, right? It may depend. What if you have the same exact? What if you have a congruent circles? Then the arc measure, the length will be same, right? Okay, so. All right, another term you should know is something called adjacent arcs. Let me move this up. Okay, so adjacent arcs. Anybody have any guess as to what we mean by adjacent arcs? It's sort of similar to angle, like adjacent angles. Do you see how they're very similar? We had adjacent angles and so forth. Kenneth, what do you think it means when we have adjacent arcs? Yeah, they're basically right next to each other. They don't define it that way. They just say this way. They say adjacent arcs of a circle are arcs that have just exactly one point in common. So here's I don't know if I have an example. Oh, I could look it up here. Okay. So look at this circle in the middle, right? What would be the adjacent arc to arc YZ in this circle? David? Look at the circle in the middle. What would the adjacent arc of this arc YZ be?
YW or ZW.
Exactly, YW or ZW. Yeah, there are two, right? Adjacent arcs for that arc YZ, right? Easy enough? Okay, you guys still writing this down? Sorry. Are you? Okay, sorry. I'll wait. But the idea is really simple, isn't it? Okay, I'll wait. So now we're gonna have a postulate about arcs. Okay. So, and we like postulates, don't we? Because we just take it as truth. So this postulate, and it has a name also. It's called Are Addition Postulate. What does that remind you of? Angle addition, or segment addition postulates, right? Anybody want to guess what this is going to say? It's really similar to those two postulates. How about somebody random. How about Jason? What do you think?
Two small arcs or
Yeah, basically you add them. You could add them together. Basically, the arc measure. So here we go. It says the measure of the arc formed by two adjacent arcs. Okay. Is the sum of the measure of these two arcs. And when we say adjacent arc, we could assume that as a definition, right? They're within the same circle. Does that make sense? Okay, because look, adjacent arcs of a circle, right? So anyway, the measures of the arcs formed by two adjacent arcs is the sum of the measures of the two arcs. Okay, pretty straightforward. And we'll do some examples. Okay, but I think you understand. Very similar idea as segment addition postulate or angle addition postulate. Okay, we're just doing that with same thing with arc. Okay. So let's apply the arc addition postulate on this picture here. Look at the picture on the right. We got a circle and you have two adjacent arcs. You see the arc AB and arc BC. Okay, what would happen if you were to add these two arcs? What would the measure of arc ABC be? If AB is 90 and BC was 110. Pretty easy. How about Jocelyn? What do you think? 200. How many people agree with her? Yeah, you just add 90 and 100. There you go. Okay. Onto these two adjacent arcs, right? You can add them together. Very simple. Okay. Any questions? All right. Another term that you should be familiar with, and again, these are very similar to what we had before. Congruent arcs. What do you guys think congruent arcs are then? Okay. How about Josephine? Any guess as to what congruent arcs are? The same angle measure? You mean arc measure? Which means that, yeah, they would have the same central angles, right? Yeah. But they do add something to this. Not only they don't just say they have to have the same equal measures of the arc, but they add this part in the same circle or in congruent circles that they have the same measures. Why do you think they have to add that in the same circle or in congruent circles? Is it okay if we just leave it out? Why can't we just say congruent arcs are arcs that have equal measures? Why do we need to include the same circle or in congruent circles? By the way, in math, do they add things that are not necessary?
No.
They never do that, okay? They try to make it as simple as possible, but they don't leave anything out. Okay, so why do you think we need that? I want you to discuss that with your group because this is very important. Go ahead. Why do you think we have to have that in there? So which group got it figured out? How about Reagan? What did your group say?
That they could be different circle sizes of circles.
Which would then be what?
Get different lengths.
Yeah, they would have different length if they're, right, from different circles, right, with the different radius and so forth. Very good. That's the idea, right? We kind of talked about this already, right? Just because they have this, same arc measure does not necessarily mean these are two congruent arcs, are they? They have to be either from the same circle or congruent circles, right? Here's an example. Okay, take a look at these two. So they tell us that the two circles, first let's take a look at this one first. Within the same circle. Anybody see congruent arcs in this circle? Yeah, there's a pair of congruent arcs, right? Who could tell me which ones they are? How about Jordan?
A, B, and C, D.
Yeah, you gotta say arc, AB and arc CD. Would you not agree? Because they both have measure of 80 and they're from the same circle. That's fine, okay? All right, that's great. What about here? Anybody see any other congruent circle other than AB, arc AB and arc CD? And notice, look at the circle P and look at circle Q. They both have the radius of 6. Okay, so are there any other congruent arcs? Joshua?
Which one?
Over here.
Oh, okay. Arc EF, the other two are.
Yes, arc EF and either arc AB or arc CD. Right? They're all three of these are all congruent. Would you not agree? Because these are congruent circles, right? All right. Then what about in this? Okay. Emily, is this arc RS, right, congruent to arc EF?
No,
No, why not? You're right.
because for the length circles are not congruent.
Yeah, the circle is not congruent. This circle has radius of 4, this is radius of 6. Do you see what they're talking about when they say congruent arcs? Okay, it has to be from either from the same circle or a congruent circles. Right? All right. In other words, the radius have to be same for the circle. All right, let's move on then. Pretty simple ideas. Okay? And now we have a theorem about arcs. Okay, so it's actually pretty straightforward. In a same circle or in congruent circles, as we talked about before, two minor arcs are congruent if, they don't just say if, they actually say if and only if. Do you guys remember when we used that, if and only if? Two people? Grace, when did we use that?
When the converse and thing are both true.
Yeah, when the statement in the converse circle is true, right? We use this for biconditional. So it doesn't just say if, it says if and only if. So you could actually change the hypothesis and the conclusion, the statement will still be true. So what are they going to say? In a same circle or a congruent circle, two minor arcs are congruent if and only if their central angles are what? Congruent. So, right? This really is saying two things, isn't that right? Right? Because it's also saying, right? This is a biconditional, right? Its statement and the converse are both true. Okay. So write this down, and this is pretty straightforward, right? In a same circle or in a congruent circle, just as we explained before, two minor arcs are congruent if and only if their central angles are congruent. Okay. So what are the two conditional statements that this is saying that are true? Can somebody give me one of them? By the way, anybody need more time to write? Okay, let me wait, and then talk about that in a minute. Good. Okay, so let's go back to the question that I asked. Who could give me the two statements that this is telling you are true? What's one of them? How about Julie? What's one of the statements that this is saying? Because this is biconditional, right?
In the same circle and congruent circles,
Uh-huh.
minor arcs
If they're what?
they're central.
Good. If their central angles are congruent, right? What's the other statement that this is telling you is also true? Because this is biconditional. Brandon, over here.
If
Actually, start with in the same circle.
in the same circle or congruent circles,
Uh-huh.
central angles are congruent if the two minor
Exactly. If in the same circle or in a congruent circle, if what do they mean by their central? If the what? If the arcs of, right? If the central angles of are congruent of these two arcs, then what? Two minor arcs are congruent. Do you see what it's saying? It works both ways because it's biconditional. We haven't had that before, I think. So please note that this is biconditional. All right. So instead of them giving you two theorems, they just kind of put it all together. Does that make sense? Okay. So there's that theorem. And let's do an example then, using what we have learned so far. Okay. So here's an example. The radius of the Earth is about 6,400 kilometers. The altitude of the Arctic Circle is 66.6 degrees north. Okay, I mean the latitude. Did I say? Or did I said something else? The latitude of the Arctic Circle is 66.6 north. By the way, what does that mean? How do you figure out? Does anybody know how to figure out the latitude? Oh yeah, you do?
latitude goes around.
Okay, so when they say this, okay, this is what they mean. Which angle? From east, if you go up this way, that's 66.6 degrees. Is that okay? So when they say the latitude of the Atlantic Circle. Now, what they want is find the radius of the Arctic Circle. Okay, do you see the circle right here? Yeah? The easiest way to kind of figure this out is, imagine that if you were to cut this top part off of this sphere, what would you get?
What's the sphere?
You would get a no, like on this top part right here. If you were to cut it, not in the middle, but this top part, where it's 66.6 degrees above from, right, this horizon, right? The latitude of 66.6. What would you get if you were to cut that part off? And if you were to look at from the top, what would you get? You get a circle. Wouldn't you get a circle? That's what they mean by the Arctic Circle. Okay? Okay, so they want you to figure out the radius of this Arctic Circle. Does that make sense? So in this picture, what are we looking for? Is it NB or is it MB? You see how we have N up here? N is the north, right? North pole. Are we talking about NB or M as in mother? MB. We're looking at MB, are we not? That's the radius of that Arctic circle. You see what I mean? That's why I want you to imagine kind of cutting off the top part and looking from top to bottom. Right? You will see a radius of that small circle, correct? That's what we're looking for. So how would you do this? Go ahead, everybody think about this. I'll wait. And go ahead, talk to your group. Okay, I'll wait. How would you figure out this MB, the length of MB? Okay, now that we really understand what this picture looks like, right? Remember this top part is kind of cut off, right? This N is the North Pole, right? So that this M is a little bit underneath, right? It's kind of inside the ground. So if I were to just draw that triangle, don't I get a right triangle like this?
Oh.
Would you not agree?
Yes.
And all we're looking for is this MB, this X, correct? And I claim that we know what the length of BO is. What is it? Yeah, how did you guys know that? Yeah, that's the radius.
Oh, I got confused with tangent.
Okay, now hold on. What is this angle measure? Wouldn't it be great if I know this angle measure? Yeah, how did you know it's 23.4? Yeah, because they said this is 66.6, right? This latitude.
It tells you right there.
North. Okay, so, all right, here we go. So if this is true, now I think a lot of you see it. Who could tell me, hold on. Who could tell me the equation so that we could solve for X? How about Hannah? Over here, what do you think?
What?
So we know that this is the right triangle we get, right, Hannah?
Yeah.
We know that this angle right here is 23.4, correct? And we got OB as 6,400 because we know that the radius of the Earth is about 6,400 kilometers. We were looking for X. We needed an equation. Hannah, what can you come up with? What kind of equation can I write here? Hint, we have what kind of triangle here? Right triangle, and we know opposite and we know hypotenuse of this right triangle. And we know the angle measure of this triangle. Okay, hold on. Shh. Okay, I'm asking Hannah. Okay, what do you think? We know the angle measure? Tangent is opposite over adjacent, isn't it? But we know the opposite and the hypotenuse.
Oh, wait.
We need sine. Very good. So sine of what? Sine of? Shh. Be quiet. 20. 24. It's about, isn't it? These are all approximate. It's about what?
X over 6.
Good. That's right. Does that make sense, guys? So, do we know what X is? Well, multiply both sides by 6,400. So X is about 6,400 times sine of 23.4 degrees.
Well, is it right now? Is it exact?
Yeah, it's exact.
Well, because they told us that first of all, it's roughly, look, the radius is about. So right now, in the very beginning, they're giving us approximations. You know what I mean? So when you punch it in, it's about 25,000 kilometers. Is that okay? So the radius of this circle on top, if you were to cut that part off, right? That's what you get. That's the radius of the Arctic circle. Any questions? Okay.
Is a question like that going
So can you do something like this for your homework tonight? Okay. No?
Yes, we can.
Okay, look at this example again then. Yes, you can. Thank you, David. Here we go.